I have restored the original vertex and fragment shaders to their original version, so we can continue with our presentation. The light calculation can be done in the world space or in the camera space. So using world space is very common, and it's the model matrix who transforms the vertex positions into the world space. And as I have already showed you in previous video, a standard way to transform normal vectors into the world space is to use the transposed inverse model matrix. So this can be done like this in the vertex shader, but to avoid extra work at every vertex position, our lab example computes the normal rotation like this on the CPU side, doing it in the rendering function just once per every frame of animation. To use a light source that rotates with the model, like a rotating desk with a desk lamp standing on it, one change that goes in the vertex shader is this, that we have to rotate the light vector by all the rotations and then normalize it. And then in our fragment shader we compute the cosine of the angle of incidence as a dot product between the normal, which is already in camera space, and then rotating light vector, also rotated with the model. So I'll upload the sample to our weekly assignments page so you can download and try this type of light on your computer. The smooth type qualifier is the default mode qualifier. That's why we don't use it with our input and output variables, but we could use this as a keyword in a shader code. And as the output vectors in our vertex shader becoming the input vectors in the fragment shader, in the fragment shader, the fragments are inserted as intermediate points in 3D space between the original vertices of our triangles. So all fragments become mathematically calculated series between the original vertices. So the fragment input variables are constructed based on ranges of outputs generated in the original vertices. This estimation of new inputs in the fragment shader is by definition interpolated inputs. Computation of both the diffuse and specular light components is done in the fragment shader of our Laboratory 7 project. So the normals are rotated right here and passed on as a vector of 3 components to the fragment shader. The light vector is also passed on like this, and so they become 2 inputs in our fragment shader. The diffuse intensity is calculated as a dot product between the normal and the light vector, clamped into the range from 0 to 1, but any possible negative intensities are obviously discarded and become 0 by using this max function. For the final color, we combine all parts, and right here, the final color, and diffuse color here, right here, is the color that we originally generate on the CPU side and now multiplied by the intensity. I use KD variable for light intensity here, as this is the old measure of luminosity in your physics book, and it stands for candela, the base unit of luminous intensity.